Solving for x. First of all, we only solve an equation or solve for x when there is an equal sign. So when there's no equal sign, when we just have an expression like this, we can't solve for x, we can only simplify. So when it's just an expression, we're simplifying. But when there's an equal sign, then we can solve for x. The foolproof way to solve for x and always know that we're going to be right is to follow the order of operations backwards. So when someone figured out that 3x minus 5 equals 4, they followed the order of operations. The first thing they did to x was they times x by 3, and then they subtracted 5, and they found out that all of that equals 4. To find out what x is, we're going to undo in the opposite order. So the opposite of subtracting 5 is to add 5. The opposite of multiplying by 3 is to divide by 3. So if you follow the order of operations backwards, you'll always solve for x in the correct order, and you will always have the right answer. So, for example, 2x equals 6. X has been multiplied by 2, so we're going to divide by 2. Six divided by 2 is 3. Now, with that example, 2x equals 6, we didn't have to use the order of operations, because we can even do this in our head. 2 times what equals 6? 2 times 3 equals 6. But as problems get more complicated, it becomes very helpful to follow the order of operations backwards. So in this case, x has been times by 3, and then 5 was subtracted. So we're going to add 5 to both sides. Add 5. Whatever we do to one side of the equal sign, we must do to the other side of the equal sign. And that way they stay balanced. 5 plus a negative 5 is zeroes out. 16 plus 5 is 21. Then the opposite of timesing by 3 is dividing by 3. So we divide both sides by 3. 21 divided by 3 is 7. Whoops. X equals 7. That's a 7. Okay. Now, again, some of you can do this in your head. But if you learn this habit now, when we get to more complicated equations like this one, you will have this process of using the order of operations backwards. You will have it as a habit, and once it's a habit, you don't have to learn it again. So who wants to learn how to solve, I forgot to put an equal sign. No one wants to learn how to solve this problem at the same time as learning the process of following the order of operations backwards. That's too much work. So you get in the habit now with the simpler problems, and then when you get to this type of problem, it won't be a problem. So, just to show you how it's done, inside our parentheses, multiplication happens first, and then the subtraction. So, x was times by 2 inside the parentheses, then 5 was subtracted, then the whole thing was squared, and then 5 was added. So we're going to undo in the opposite order. First we will subtract 5 from both sides. Then we will take the square root of both sides. Then we will add 5, and then we will divide by 2. And just to show you how easy this is, I'm going to do this problem without even dealing with the left side. I already know what I need to do. I'm just going to look at the right side. So here's my 1 from the right side. I subtract 5 and I get a negative 4. I'm going to need more space. Okay, so I've got a negative 4. I'm going to take the square root of that, which would be 2i. Remember, a negative square root of a negative 1 is I. Then I'm going to add 5 and then divide by 2. And actually it's probably plus or minus all that. And that gives me my answer. 2x minus 5 squared plus 5 equals 1. So again, I subtract 5 from both sides. This is just to show you that I get the same answer. Subtract 5 from both sides. Then I take the square root of both sides. Then I probably should have done my plus or minus to begin with on the other side, because I think I made that little mistake. Because it's just the 2i that's plus or minus, and I put parentheses around it. Let me fix that. We get the same answer. Plus or minus 2i plus 5 equals 2. And how that's usually seen would be 5 plus or minus 2i all over 2. Oh, but again, that's just an example of why we need to learn this. That last one is just an example of why it's a good idea to get this using the order of operations as a habit now. Because, so this you don't need to worry about. Oops, don't need to worry about this one right now. That's for Algebra 2. That's just an example of why it's a good idea to use the order of operations now while there's still simpler equations. So you're going to use the order of operations with this type of problem and this type of problem in Algebra 1.